network. Disruption tolerant. So let's go to our room and do it if you move. Yeah, perhaps. Okay, hello everyone. Welcome to the noisy meeting of the 6LO working group. Please make sure that you are in the right room. My name is Carlos Gomez. The other chair is Shweta Bandari, but today she's probably not going to be able to join. So we asked Laurent Dutan to help us delegate, and we would like to thank Laurent, as usual, for the help. Our responsible AD is Eric Winke. And yeah, we still need some minute taker for the session. Is there anyone who would like to volunteer? Thank you. Thank you very much. Okay, so recall that we are using HedgeDoc to take minutes. So everyone feel free to join and contribute as well. So there are a few meeting tips for in-person participants. Please make sure that you sign into the session by using Meet Echo. You may, for example, use the on-site tool from the data tracker agenda if you wish. Recall that you need to use Meet Echo to join the queue. There's a single unified queue. And also it's very important that blue sheets are automatically generated from Meet Echo. So please do join the session. And for remote participants, just keep your audio and video off unless you are presenting something. Okay, this is the Notewell. Perhaps you may have seen it several times already during this week. But anyway, this is a reminder of the IETF policies, which are in effect on several topics which are important, such as patents or code of conduct. For example, recall that as a participant or attendee, you agree to work respectfully with other participants. I'm not personally aware of any issue in this regard in this working group, but anyway, a reminder is always good, perhaps. And yeah, please make sure that you have read the note well. And this is the agenda proposed for today. First, we have the usual chair's introduction, which is currently in progress. The second presentation will be given by Pascal on the IPv6 neighbor discovery prefix registration. Then Luigi will present two documents which are related. The first one is the base PASA draft, the path-aware semantic addressing for LLMs. And the second one is the generic address assignment option for 6LoWPAN-ND. And after that, I will present the draft on transmission of SHIP compressed packets over 15.4 networks. And finally, Yang Wan will present the transmission of IPv6 packets over short-range optical wireless communication. So this leads to a total of 80 minutes of allocated time. We requested 90, we got 120. So yeah, we have some margin in case more discussion is needed. Other than that, is there any comment on the agenda? Okay, so seeing none, then let's give the usual report on the working group document status. As you can see, we have 5 working group documents at the moment. The first one is already in the RFC editor queue. That's the IPv6-ND multicast address listener subscription draft. The next one is path-aware semantic addressing for LLMs. We received a couple of early reviews for this draft. one from the general area, the other one from the routing directorate, and as a result, the draft has been updated several times since the last IETF, and it will be presented today. We have also the SHIC transmission of SHIC compress packets over 15.4 networks, which has also been updated as a result of trying to align with the work on the SHIC architecture that's being done by the SHIC working group. Then we have also the IPv6 ND prefix registration, which for which we received also 2 early reviews, one from the general area, the other one from int area. And as a result, the document has also been updated and will also be presented today. And the last draft on IPv6 over short-range optical wireless communication, it was adopted after Brisbane, and it has been updated since then, and it will be also presented today. So are there any comments or questions? Okay, so if there are no comments, then we can proceed to the next presentation, which will be given by Pascal.
Hello, Carlos. Hello, all.
Hello, Pascal.
Can you hear me okay?
Yes.
Okay. Do you want me to move the slides? I can do that if you transfer to me.
As you wish. What do you prefer?
I can move them.
Okay. Yeah, we don't need to give you the control because you have access as the role of delegate, right? Yeah.
How I could grab the controls, what you're telling me. Doesn't seem so.
Yeah. Now,
okay, I have it now.
Now
Thanks
we
so much.
pass the control to you.
Yes. So yes, this is about the IPv6 neighbor discovery prefix registration. So as some of you know already for a while, this is part of a family of documents that this group has elaborated over the years, started from 6LoWPAN neighbor discovery, which was updated with RFC 8505. And as Carles has mentioned, we have the multicast registration, which is now in the RFC editor queue. That was a requirement coming from the industry for, in particular, metering applications. They wanted a simple multicast service, just like they have a unicast service. They don't want to use MLD that doesn't fit the IoT model where the devices sleep. So we did this multicast registration. And now we are extending this work even more for prefixes because more and more we are talking about giving away prefixes to devices. There is one left which has been on the back burner for a while, which is the unicast lookup. As soon as we have those databases, centralized or distributed databases of addresses in the subnet, it would be very cool to be able to look up that database as a unicast as opposed to using broadcast for ND address lookup. Once we've done this prefix registration work, I hope we can move on to the unicast lookup. So yes, we've registered address, we have registered unicast, multicast addresses. Let's be for prefixes. And why are we doing this? Well, first thing, some hosts will want prefixes. And forms of host could be phones, for instance. And if you own this prefix attached to you, then there is no need for routing to get to the prefix. If you tell your neighbors, hey, I have this prefix, they can just give the packets to you for whatever address in the prefix. There is no really routing involved. And that's why neighbor discovery is a fine mechanism for providing first up communication to a prefix. So multiple applications, there is this concept of network in a node, like something looks like a node to the outside, but inside it's a network. There are another use case is Kubernetes. We could provide a full 4 bytes address IPv4 realm, hidden inside a prefix like a /96. And so we would just register /96 to the router and define an IPv4 prefix inside that and map that to Kubernetes. And then, like I said, anything directly connected, and there are some usages. For instance, in op networking, you connect a router that has a prefix to your home network, and you would like the whole home network to be able to reach on the other side of that router. You need to announce the prefix in the home network, but you don't necessarily want to support any particular routing protocol. Then again, ND is a good agnostic method to just tell the other routers on the home network that this particular router has this prefix. So how do we register a prefix? Well, it's the same arrow option or arrow option as we have in 8505, and we're using for unicast and multicast addresses. The idea is once a node registers a prefix to its router, if the network, the subnet, is actually a larger subnet, then the router can inject that prefix in the subnet gateway protocol. And that's what we are discussing at 6man in the IPv6 over wireless draft. That there is an R flag, which was already defined in 8505. The idea is, yes, I want the SGP to redistribute my prefix, or no, I don't want the SGP to redistribute my prefix. And why would I want not to redistribute? Well, because maybe I have also registered to a different router and I have asked that other router to redistribute the prefix. So you don't want necessarily all the routers you register to redistribute the prefix, because that could be a lot of routes in the subnet. One little comment is we are using the I field, which is being saturated. So there is this F flag that was discussed in the draft, which is kind of complex. It's about whether on which side the prefix is. And well, maybe we'll just abandon that idea. I didn't get much feedback on this, but if people could read the draft and look at this F flag discussion, probably would say, okay, it could be useful, but the picture becomes complex. Example of use case. Then again, that's a cloud like Kubernetes use case, but you could figure also home network where all this infrastructure is just your home. You have this host on the bottom, which is effectively owns a subnet. In the case of Kubernetes, you could have a full IPv4 realm or a 10 dot private addressing, and you inject the /96 to say, hey, I own this prefix. And in this case, you see the router on the left injects it with the R flag on, meaning that it's being redistributed, but it also injects it to an alternate leaf saying, hey, don't inject that in the routing and get the traffic back through L1. But if L1 dies, then I will tell L2, hey, now you need to inject the prefix for me. L being the leaves to which the devices are attached. And this kind of deployment is EVPN or Rift. In Rift, we already discussed the use of 545. So this is basically extending the capabilities.
Pascal, sorry.
Note that there, sorry?
Yeah, because there's some noise. I'm not sure if you can hear it, but there is some construction noise around. Can you maybe increase somewhat, like speak louder or closer to the mic? Sorry for that.
Okay, I can speak closer to the mic, but my mic is at 100%, so I cannot set it higher. So yes, I'm speaking closer now. You can see my face in full. I'm sorry for this. So yes, there is this important work at v6ops about DHCP prefix delegation per device. So the idea is, yes, now you can get from DHCP, you can get to /64, for instance. Okay, or I would say maybe a larger, longer prefix if you want multiple prefix inside one /64. Anyway, so you're getting this prefix from DHCP prefix delegation. Question is now, how does the router know that this prefix has been allocated or deallocated by DHCP? The way it's done today is like secret sauce between the DHCP and the routers. but there is no really official connection between them. So if you wanted to take the DHCP server and the routers from different vendor, we have this hole on how to effectively tell the router that this device has the prefix. Now, with this draft, not only can we obtain a prefix from DHCP and now declare it to the routers we want to talk to, but at the same time, we can also prove the ownership using the rover option, which we already defined since 8505, and that has become trustable with 8928. So we have a way to get the prefix, get associated to a public key somehow, and have this information published to the DHCP server so the router can check later if this DHCP server effectively associated this prefix with this particular public key. And now if the host can prove that he owns the private key, then the router knows he can inject the prefix for this host. So you see, we have a way to provide this trusted communication and trusted injection of the prefix from the DHCP to the routers. And that's very important. That's the missing link, basically to make this draft IETF sub DHCP PD per device fully functional. So what's new? Yes, as Carlos said, we've got those two reviews by Dave Thaler and Dan Romascanu. Thank you both for those reviews. I did not fully process Dave's review because there are a lot of typos that he has fixed in a document that was attached, but I could never get. So when I published, I could not do it. And then there was the cutoff. Dave has sent me since the full document with all the notes. I have to apply those changes and publish again. The salient point from Dave's review was this draft just discusses unicast prefixes. There is no way to register multicast prefixes. So I never thought that we could need that. But since we are using the P field and there was only the value 3, it's 0, 1, 2, 3, it's 2 bits, only one value left that was designed to be used for prefixes. Now we are using it as designed, but there was never the idea that there would be a need for anything but unicast prefixes. So if somebody thinks sees an application for declaring a multicast prefix, it's a good time to talk because after that we don't even have room in the P field anymore. So that could be a problem. Or we allow for unicast and multicast prefixes. Right now, the text is kind of unicast. So if people think, you should use it for both unicast and multicast prefixes, well, probably we can declare that. I mean, it's easy to recognize a multicast prefix from just the FFFF on the first byte. But, well, the question is open. For now, I don't see a need for multicast prefixes, but maybe I'm missing something. So please discuss that on the mailing list or come to the mic if you see that it's useful. For Dan's review, the salient point I would say was that he would like to beef up operational consideration sections. We already have backward compatibility, but it is more about operations. So we did that already for the multicast registration. So why not do it for the prefix registration? I see a number of things that we can do. So probably on the next revision, you will see an operational consideration section wrapping the backward compatibility one. Then there was this question about the title for the section that has all the must and should, etc., BCP 14. And the title is always the same in every document I write. It's called something like requirements language. And Dan was surprised by this title. It's not mine. I mean, Eric, if you're in the room, tell me if this title is right or wrong, but that's what I've been using everywhere. I think that's the official title for it. So I was surprised that Dan was surprised, let's say. And that's pretty much it for this draft. So I would be glad to take questions. Eric?
Eric Vink, so bonjour Pascal.
Hello, Eric.
Requirement language is typically used, so I don't know exactly where it's coming from. Now, I got a more fundamental problem with the draft. I don't see which point of the charter it fits. Because it's close to routing somehow because you modify
No, it's
role.
not routing, Eric. No. I won't take that. It's not routing at all because there is no
REPL
route.
document.
There is no path computation. There is no path.
But you update REPL document.
Sorry?
So I will check with John Scudder, which is the responsibility for role,
please.
to see whether it's a problem for him. Or anyway, there would be a solution, right? So that's no problem. The draft, if the community wants to get it, it will be published, right? So take my word on this. My only problem is that I don't want to wait until ISG evaluation. Then a colleague of mine says, hey, it doesn't fit the charter. And then it's sent back to the working group, right? So it will be much
I see,
worse.
Yes,
So I want to prevent this issue.
look at
That's only
that.
this.
I would like to give you my argument when you discuss with John. My argument is a routing protocol computes path. Here we are talking to the routers which will do the routing protocol. We are giving them the information that they will need to inject, but there is no path computation there. Just look at the router preference in arrays. It's not routing. It's just it tells the host use this router for this prefix and that router for that prefix. That's no routing. There is no distance. There is no path computation. It's plain ND. And here it's exactly the same level. On the other direction is the host saying, hey, I have this prefix, but I'm not giving you a cost. There is no path to compute. You just can give me the packets if your destination address fits my prefix. But don't compute a route. You may inject it in your routing protocol, but I don't know how you do that. I don't participate to the routing protocol. See?
But again, I will talk with John Kuder because you're updating role document. And I don't think it's really in the charter here.
But now you have my argument. But okay. Thank you, Eric.
Okay, there is also a comment from Christian on the chat about whether this work is being coordinated with SNAC Simple by Ted Lemon and other authors.
That's a perfect comment. And actually, I presented it at the first SNAC meeting. And there are examples in the document about how you would use it in SNAC. And this F bit, which is a bit complicated, is effectively for a use case I saw for SNAC. But I don't seem to be getting any feedback about whether this F flag would be used by SNAC. And like I said, it's a bit overly complicated. So maybe we'll just remove it. But anyway, yes, it would be good at the next opportunity to go back to SNAC and present this draft again. I would love to have discussions on this draft, copied the SNAC mailing list as well. So that's yes, it's one of the big use cases. So certainly that's a very good question.
Okay, thank you. Any other comment or question?
Thank you. Thank you, Carlos.
Thank you, Pascal. So the next presentation will be by Luigi on the PASA draft and the GAO draft. Yeah.
Okay. Hello, everyone. I will give you an update on the PASA document. Since last time we met, we actually submitted 3 new...
Sorry to interrupt. You're barely audible on the remote participants. Please check that.
The remote people do not understand you, do not hear you. We hear you.
Yeah, of course, the mic is off. Okay. Better?
Much better, thank you.
Okay. I was saying, since the last meeting, 3 revisions. So the first one was a simple affiliation update, so I will not go over it. The other 2 are about the reviews that we received. The first one is a general art by Paul Kizivat, if I pronounce correctly. The second one, a couple of weeks ago, is Joel Alpern that sent the reviewers from the routing directorate. Okay. Now, skipping the first revision, I mean, between revision 5 and 6, as a structure, there are no changes at all. At the beginning of the document, we inverted the definition of PASA host and PASA router, just because actually the process is that when nodes come up, first it takes the roles as a PASA host, looks around to connect to the router or the root, and then if itself has to be a router, then switch the role. So it makes sense to have the root, the router, the root, the host, the router. Okay. And also, since the specific address allocation function that we describe in this document is tree-based, we switched an acronym to TAAF as the address allocation function. We did some clarification about how it works in the case of the PLC. Just to recall, in the first part of the document, we have an extensive section about use cases. So we need to add some clarification in the specific PLC functioning. And then we added some clarification text here and there, which was important, and it was a good point, about the usage of non-volatile memory. Because like in other documents, if by any chance a node restarts, so basically what it does, it checks in the non-volatile memory. If it has some state, it can re-register, okay? So the text then has been updated in a few places in order to consider this case, and also in the reliability consideration section. And some editorial stuff in the section 6.1. There is an extensive example on how we build the addresses. So we adjusted a little bit the rendering so that it is more clear. We added some explicit text how to go from IPv6 address format to the very short PASA format. So basically the bits that are more interesting. We updated a misleading picture. So on your left-hand side, you have the previous picture. As a symbol of the nodes, we were using a capital letter O, which was misleading, like a 0, which was part of the address. So now we use double parentheses, which is reasonable, I mean. And that were the changes from 5 to 6. So this was the revision from Paul. Now on the changes that we did following the Joel's review. Again, no changes in the structure whatsoever. We didn't need to revise completely the document. We added some text in section 5 in order to better, more explicitly clarify why we are exploring PASA. I mean, there are two things. One is about the length of the addresses in a certain way, and the other is the fact that in the specific use case that we described in the document, in the specific context, you don't necessarily need to run a full-blown routing protocol. Having said that, this document doesn't claim that it's a replacement for REPL or other solutions. I mean, it's an engineering choice, it's another option, nothing more, in the specific context of this document. Then there was, when we described how the algorithm for the forwarding part works, rightfully Joel pointed out that it's clear, but there is a lot of assumptions that come from the first part of the document. So we added quite some text in order to really go thoroughly what is the logic behind the algorithm, and a couple of definitions about how we compute the length of an address and whether or not it's the prefix of another address. So the revision 07 of this document has been submitted on Monday, just because we received the review during the period that we were not allowed to submit a new document. We sent a reply to Joel, and this part is already fine for him. There were minor observations also on the fact that the IANA section, usually we don't suggest values, we use to be done 1 and 2. And we rephrased something in section 12 because one of the comments was, what do you do if you have multiple routes, which is something that is important. Apparently this text is not sufficient according to the last email, but I mean, we are making progress. As for the last email received by Joel as a reply of this submission, we have 2 open points. One is the fact that how you can set up multiple routes, so that because it's important to have a redundancy. And the other point is about whether or not this document should be standard track or experimental. Now, there are arguments on both sides. I mean, this document leverages a lot of mechanisms that are already standard track. At the end of the day, what it does is just a different encoding of the path to be followed in order to reach the destination. So it's not that different than REPL in non-storing mode, if I recall correctly. So basically, it's a different encoding. It's also true that it's an encoding that never has been used. So we will discuss with Joel and see what is the more reasonable status for this document. If you have any comments or question on this one, Eric, please.
Eric Vane, and I'm afraid that we need to make the same comment as for Pascal draft. Yours is even more routing, and routing is forbidden in the Charter of 6 law.
And it's not routing. We don't do routing, actually. We do addressing, and then we use the address in order to do a forward operation, which is in the Charter. Well, we can discuss more. I'm not...
Anyway,
it's just my argument.
I will repeat what I said to Pascal. Anyway, your draft will be published in RFC if the committee wants it, right? So that's not a problem. But I want to address the problem as early in the process because it's more efficient. That's all my point.
Absolutely.
Pascal?
Yes, actually, Joel also mentioned something similar to what you're saying, Eric, and I had pretty much the same answer that we just gave you today, which is the route is the path is already there when this PASA procedure comes. The tree is already built, meaning the routing has been done. It's just that the path itself is written nowhere. And so you have to write, the routing, quote unquote, has to write this path somewhere. And what's happening really is the path is written into the address. And that's where PASA starts. The routing has been done, the routing is finished, the tree is built. PASA starts when, after the routing has been done, you have to write the route somewhere, and PASA offers you a way to quote unquote save on the source route. I mean, that's the analogy with REPL non-storing mode is you write the path as a suite of addresses in the source route header. Here, you write them inside the address. But think about it, the routing header is not routing. Even if it's called a routing header, RH0 is not routing. It's just the expression of a path, but it's int area. It's not routing area. It's an IPv6 architecture. And here, same thing. We are just condensing things inside the address. SRv6 is doing something like that now as well. So well, you would tell me SR is in routing, but to do that, they have to come to int area to effectively ask us to do it. So I think we are plain int area and not routing area at all. That would be my claim.
Okay, so stop sharing this set of slides and request the others. You should see the request for the other set of
yeah.
slides.
Okay.
Okay. So for the GAO document, we have only simply one revision in the meantime. We revisit mainly the message sequences, and we try to improve the clarity as much as possible. This is also thanks to the help of Adnan that joined as a co-author of the document. We were discussing for 2 IETFs now, so he happily joined in and helped a lot. Also to remove a lot of typos and to update the YANA section and the other part. The main changes are not technical, it's just improved text. As you may recall, what this document proposes is to have two different phases. One is a request phase when a node comes up, that can I get an address? And the second phase is I confirm that I will use this address, okay? And this second phase is optional. It depends on the router that gives you the prefix or the address and say, I want confirmation, basically. Okay, so we organized the text around two explicit subsection, okay? On the request side, there is not that much new. On the optional confirmation side, also we just reorganized in a more explicit way. In this one, we added some, at the end, some text about the reboot case, because what happens, so because we have two phases, what happens if a node has to reboot or by accident or willing? You check the non-volatile memory. If you have something, it means that somebody told you already which prefix or address to use. So in this case, what you may try to do is to just try to re-register the prefix or address, okay? But in case this doesn't work, this is an error by any chance, what you do is, if you restart from the beginning, making an explicit request, okay? Same thing is if you come up and you don't have anything in the non-volatile memory, you start from the beginning. So basically the request phase. Okay. And then we added a section about the message exchange optimization, because actually this option can be piggybacked in several messages. It can be used for example, during a registration transaction. Basically, you want to register a link local address. In the same message, you can put this option asking for an address, right? And when the reply comes back in order to confirm the registration of the link local address, we can also send back the GAO option with a proposed address or prefix. This can be done because actually the way it has been defined, the proposed address or prefix is inside the option itself. So we don't use the target link local address option, so which is used for the link local registration, right? Actually, things can go a little bit further in the sense that in principle, you can embed this option when you come up, when there is the routing solicitation and routing advertisement exchange, meaning that the node comes up. What it does is to send around a routing solicitation. It can put the option in order to ask directly for an address, okay? And if the router supports the option, it can add back the option in the routing advertisement. Otherwise, just ignore the option. I mean, nothing to do. That's it. Yeah, we think the document is relatively stable. As I said the last time, we do another revision and maybe we consider to adopt this document in the working group, and then we are here at this point. Yeah, we may consider to adopt this document, and as usual, all help is welcome.
So you mean you plan to do another update?
No. That's what I said last time, to do another update.
Okay.
We did it.
Okay.
It's time to consider.
So let's, yeah.
Sorry for not being clear.
No. Sorry. Okay, so yeah, let's have a show of hands to ask about adoption for this draft. So I'm writing it. So you should be seeing the show of hands. Okay, so the results are getting stable. At the moment, it's 7 yes, 0 no, 3 no opinion. So yeah, let's maybe terminate. Okay, so yeah, so again, maybe for the record, for the minutes, the result of the show of hands was for the question, are you in favor of adoption of the GAO draft? There are 7 yes, 0 no, and 3 no opinion. So yeah, there seems to be support in the room. And as usual, we'll also confirm on the mailing list.
Okay.
So thank you. Cannot share slides. Luigi, do you still have control over the slides? Okay, we are trying to share the next slide set, but
You assume that everything goes.
There is a small
so we are connecting again. Okay. Yes. Okay. Okay, so now I'm going to present the last update of the draft entitled Transmission of SHIC compressed packets over 15.4 networks. My co-author is Anna Minaburo. Next, please. So a reminder on what is the main goal in this draft. What you can see on the left is the traditional IPv6 based protocol stack over 15.4, which is enabled by using 6LoWPAN as the adaptation layer, which provides header compression and also fragmentation, among others. And what we want to do is what you can see on the right, which is offering the alternative of using SHIC as a technique for header compression in the same environment. This is because the expectation is that SHIC should provide a greater compression ratio and therefore better performance. Next, please. So today I'm presenting version 06. There are several updates, most of them as a result of trying to align with the latest developments in the SHIC architecture draft. So that's a SHIC working group document. The content that I'm presenting today is the result of a couple of presentations and discussion in 2 SHIC working group interims. And also there are some other updates of other types throughout the document. Next, please. So this is the changes in the table of contents. There are basically 2 changes here. Both of them are related with aligning with the SHIC architecture draft. So first is section 3.2 on SHIC architecture concepts. And then there's also in section 4, there's a subsection on the SHIC header. Next, please. So first of all, for those of you who maybe are not following the discussion in the SHIC working group or did not attend the session on Monday, just some background concepts, and then later we'll see how we apply them in our draft. So first of all, in the SHIC architecture draft, there's the concept of SHIC stratum, which would be somewhat the layer, the location of at which SHIC operates. And then in one such stratum, there is one SHIC header, which indicates the SHIC packet instance to be used to decompress a SHIC packet. So there is one SHIC header instance. And then on top, there can be like several possible instances of a SHIC packet for compression, decompression, okay? And then we have another parameter, which is external to the SHIC data units, which is a discriminator, which indicates the SHIC header instance that's needed to decompress a SHIC header. So the discriminator tells how to decompress the SHIC header, and the SHIC header tells how, which is the SHIC packet instance that you need to use to decompress a SHIC packet, in the case when there are several possible SHIC packet instances. Okay, so next, please. So how do these concepts apply in our draft? Well, we've added section 3.2, SHIC architecture concepts. First, about the SHIC stratum. In the draft, what we do is that SHIC is used to compress IPv6 packets over 15.4 networks. So in this case, the SHIC stratum is located on top of layer 2 and below layer 3. One aspect to consider here is that the compressed data of the SHIC stratum may also comprise upper layer packet headers. So there are different possibilities. SHIC may be used to compress IP headers, or perhaps IP/UDP headers all at once, or maybe IP/UDP co-op all at once. Then we understand that the discriminator in this case would be the first field in the 15.4 frame payload, which is the 6LoWPAN dispatch. In this case, when set to the SHIC dispatch or SHIC pointer dispatch, it indicates that what comes next is a SHIC data unit. Next, please. Then we have also introduced a couple of concepts for the analysis of how we apply the SHIC architecture concepts. One is the single instance networks, and on the next slide, we talk about multiple instance networks. So in the first one, single instance networks. These are networks where all the nodes have a single SHIC packet instance for compression, decompression, CD. And therefore, each node has a single set of rules for SHIC packet CD. In this case, then, because the SHIC header indicates which is the SHIC packet instance you need to use, because there's only one here, one instance in single instance networks, then, okay, the SHIC header can be fully compressed down to 0 bits sent over the air. And because it is possible to do it like this, then in the draft, we state that it must be fully compressed for single instance networks. Then also all network nodes have a single SHIC header instance and a single set of rules for SHIC header CD, which in this case is kind of empty, equivalent to comprising a single implicit rule for SHIC header CD for all the nodes. Next, please. So about multiple instance networks. These are networks where at least some of the network nodes may have more than one SHIC packet instance for CD, and therefore there will be one set of rules for each SHIC packet instance. So some of the nodes have several sets of rules. And it is possible that there could be, say, rule ID 2 in one instance, rule ID 2 in another instance, and they could be different rules, okay? So for this reason, we need a SHIC header, which in this case cannot generally be fully compressed, because we need something, in this case the SHIC header, to tell when a node receives a SHIC compressed packet, okay, which is the instance that needs to be used for the decompression. So it means that with one exception that I'll mention later, in this case, with multiple instance networks, we need this SHIC header, which will represent, when transmitted in compressed form over the air, more than 0 bits. Also, all network nodes have a single SHIC header instance and a single set of rules for SHIC header CD. But in this case, the set of rules may comprise maybe one or maybe several rules for SHIC header CD. Next, please. Okay, so you may recall that in this draft, one of the main problems is trying to enable multi-hop communication, how to deliver a packet which is compressed by using SHIC end-to-end in a 15.4 multi-hop topology. So recall that for that, we have 3 route over modes, and we also have mesh under. And now we need to consider both cases of single instance networks and multiple instance networks. So you will see that, well, we'll go through one example for each one of these cases, although some of the conclusions, as you will see, can be sort of generalized. So this is one example with a single instance network. In this case, basically, this is in straightforward route over SRO, which means that the nodes, like the 6LRs, intermediate nodes in the network, need to store all the rules for CD, for compression, decompression, which are being used in the network. So imagine that host A transmits a packet to host B. Well, then it will use rule ID 1 to compress the packet. It will send the SHIC compressed packet to the next hop, which is the upstream 6LR. And the upstream 6LR has single set of rules because this is single instance networks. So it just uses rule ID 1 to decompress the packet and perform its routing decision, and then compress the packet again and send it to the next hop, and so on until the packet reaches the destination. So because this is single instance networks, you have seen how things just operate correctly without ambiguities. The SHIC header is compressed down to 0 bits. And of course, for this to operate correctly, we need that a rule and its corresponding rule ID must be unique network-wide. However, the means to ensure this are out of scope of the draft. Also, to simplify the management of rule IDs, because this could be a challenge for bigger networks, in SRO, all nodes in the network may share the same set of rules. Next, please. So what happens in still straightforward route over, but now with multiple instance networks? So in this example, now there are 2 possible instances. So the nodes have like 2 sets of rules. And in this case, for example, let's say that host A receives the SHIC compressed packet with rule ID 2. Okay, the question is, as you can see with the red arrows, there are 2 possible rule ID 2, one in instance 1, one in the instance I2. So, okay, host A may wonder, which one is it? which set of rules do I need to use, which is the instance that I need to use. So for this reason, we need the not fully compressed SHIC header, which will tell, okay, which is the instance you need to use, right? Next, please. Then the second route over technique is called tunnel-based route over. Here, the assumption is that the network is running REPL. By the way, there's some of the terminology about the host that still needs to be updated. That was a comment by Pascal. And yeah, the assumption is REPL is being used here as the routing protocol in non-storing mode. And then as a way to avoid the 6LRs to have to store all the rules in the network, then what we have is tunnels. So if host A wants to transmit something, then there's a tunnel from host A to the root of the network, which is the 6LBR in this case. And then if the destination is internal to this network, say host B, then there will be another tunnel, downward tunnel from the root to host B. So in this case, basically, imagine that, again, host A wants to transmit this packet from A to B. Then it compresses the packet with rule ID 1. So the SHIC compressed packet is carried, encapsulated in the tunnel. The root will receive the internal packet and will say, okay, it's rule ID 1, but it is clear which rule it is because this is single instance networks here. And then it will decide, okay, my destination is host B, and it will send the SHIC compressed packet down to host B. So again, this is single instance networks, so the SHIC header can be, and it is, compressed down to 0 bits. And also, to avoid ambiguities at the 6LBR, a rule and its rule ID must be unique network-wide. However, the means to ensure this are also out of scope, although it's easier than, of course, in the straightforward route over. Next, please. What happens in same approach, tunnel-based route over, but if there's multiple instances here, okay, again, we need a not fully compressed SHIC header. Again, imagine that host A receives a SHIC compressed packet with rule ID 2. Okay, is it the rule ID 2 in instance 1 or the one in instance 2? Okay, the not fully compressed SHIC header will tell which one to use. Next, please. The third and last route over mode is pointer-based route over. Sometimes we call it PRO. In this case, recall that there is a pointer that is prepended to the SHIC compressed packet, which will allow any node that receives the SHIC compressed packet with the pointer to find the location and the size of the residue of the destination, IPv6 destination address, so that imagine that the 6LR in the middle, it doesn't store the rules, but it can still determine, it can reconstruct the original IPv6 destination address because it knows the prefix, and then it can find the compression residue. So in this case, a packet is routed. The routing protocol doesn't have to be REPL, but it's routed from the source to the destination. And the advantage is that, again, as in TRO, we don't need to store the rules in the intermediate 6LRs. So can you please go back? Yeah, thank you. So here in single instance networks, again, there is no ambiguity about which rules need to be used because this is single instance. So the SHIC header is compressed to 0 bits. And then another point is that in contrast with the previous techniques, a rule ID may be used to identify different rules used by different pairs of endpoints, such as highlighted on the right of the slide. You can see that nodes A and C use one rule, which is identified by rule ID 2, and then nodes D and B have another rule. It could be different, but has also the same identifier, rule ID 2. There is no issue because this is single instance networks and there will be no ambiguity in this regard. Next, please. If it's multiple instance networks, again, same reason as before, we need a not fully compressed SHIC header so that a receiver can determine, okay, which is the instance that needs to be used to decompress any incoming packet. Next, please. Okay, finally, we have mesh under. So first, there's, if you can go one back. Yeah. Thank you. Yeah. So first, in single instance networks, it's mostly the same as in Pro. Of course, here we have mesh under, and the nodes in the middle are mesh under forwarders and so on. But the conclusions are all the same. The SHIC header is compressed to 0 bits, and also a rule ID may be used to identify different rules used by different pairs of endpoints. Then in the next slide, in multiple instance networks, here there is some interesting exception. Because in this case, even if there's multiple instances, it is possible to fully compress the SHIC header, at least in some cases. For example, you may see that, again, we take the host A as a possible destination. There is one rule ID 2 in instance 1, and the sender there could be node C. And there's another rule ID 2 in instance 2, where the sender could be node D. So the host A may receive a SHIC compress packet with rule ID 2, and it might wonder, okay, which one of the two instances do I need to use to pick the rule to decompress the packet? Well, in this case, because this is mesh under, it is possible to tell which is the instance because there's a different sender in each case. And the mesh header includes which is the source of the packet. So as long as it is possible to tell from the source which is the instance, then it is possible to fully compress the SHIC header here as well. So next, please. Okay, so then in order to introduce the SHIC header, we have updated the frame formats in the draft. So basically what's in red is new. The previous format is everything else. So this one that you can see on the slide is the one for straightforward route over, also used in single hop transmission. And basically what you can see is, yeah, the whole data unit is the 15.4 frame payload. And there is the SHIC packet, which is the packet that has been compressed by using SHIC. And then it is preceded by the SHIC header, which again, in single instance networks, it represents 0 bits in compressed form. And in uncompressed form, it will be something like, well, in uncompressed form, we still need to define it, but in compressed form, it will be something like a rule ID and a compression residue. So in multiple instance networks, where generally we cannot fully compress it, in that case, we recommend the rule ID size to be between 1 and 8 bits. Next, please. Okay, these are the formats for TRO, for downward transmission when the source is not the root, when the source is the root, or upward transmission. Again, what's in red is the new part, which is the SHIC header, which precedes the SHIC compress packet. Next, please. And here we can see the updates for the formats for Pro and Mesh Under. For Mesh Under, it's also similar. Actually, well, this is one of the options for Mesh Under, but anyway, basically we have the SHIC compress packet, and the SHIC header precedes the SHIC compress packet. And the case which is slightly different is the one in Pro, because what you can see on top of the slide is basically the Pro header. So this is what precedes the SHIC compress packet. And because of that, the natural location for the SHIC header would be after the Pro header and before the SHIC compress packet. However, there is one reason why we thought that it might be a good idea to insert the SHIC header in the middle of the Pro header. And the reason is that we wanted to keep the bit pointer as simple as possible and keep it independent of the SHIC header. That's because the bit pointer indicates after the address length how many bits you have to count until you find the compression residue for the hop limit and the IPv6 destination address. So by doing this approach, the bit pointer stays as it is, and we do not complicate its operation. Next, please. Yeah. So there are also other updates in the draft. So all the previous ones relate with aligning with the SHIC architecture. Now, there is a section in the draft about neighbor discovery. So one thing that we have updated is that compression of ICMPv6 headers is now being developed in the SHIC working group. Another point is that we got some early review. Yeah, Laurent, maybe?
I don't know if I move to the mic. It's maybe better for the camera.
Okay.
So for the compression of ICMPv6, we say that we stay on RFC 44, 43, if my memory is good. So it means that we don't cover neighbor discovery.
Okay, yeah, so it means that there is some part of the ICMP messages which will be compressed, but the rest is not.
So we don't, yes, yeah, in fact, we have just the error messages and ping.
Only.
Yeah.
But there are also fields like the ICMPv6 headers, I guess. I think I read.
Yes, there is a format for ICMPv6 header.
Yeah.
And of course, it's just IP, but the content is viewed as a payload, and there is no deeper analysis of what we have inside.
Yeah, thank you for the clarification. So perhaps it might be interesting to consider even chic to compress the payload of those messages, but still this is intended to say that, okay, we have some way to improve a little bit the transmission of ICMP v6 messages carrying neighbor discovery messages by using chic, okay? Well, let's see if we develop a bit more or not. And okay, then the other point is about IANA considerations. We got an early IANA review, and basically the content of the considerations was already okay, but the format, they requested us to put the content in this table that you can see on the slide. So yeah, we basically modified the content and put it in the format of this table. So yeah, just recall that this is the request of fields, bit patterns for the 6-loop undispatched type, one for chic in page 0, in page 1, and also for the chic pointer in page 0. Next, please. Yeah, so we also have one addition in the security considerations. This was a comment by Pascal, that yeah, now in Pro, we have the pointer. So that creates new attack opportunities, right? So a malicious node might modify the related fields, and that would be with the aim to avoid the packet reaching its intended destination, producing some error there. So we understand that the appropriate use of link layer security might mitigate at least the threat. And finally, you may recall that we have Appendix B in the draft, where we try to see which are the pros and cons of all these different route over modes that I presented before. And however, we had modified a little bit the header and somewhat the functionality of Pro recently in the last draft updates, but the appendix hadn't yet been updated, so now it is up to date, okay? So I guess, next please. Yeah, that was my last slide. I don't know if there may be comments or questions. Okay, so if none, then I guess that we can proceed to the final presentation. Can you? I still can't. I maybe should log out and log in. So it's the last slide? Yeah, this one. Yeah.
Okay. Maybe we ask.
Can I use that one?
No.
You need.
No, you have to use your application.
Yeah, maybe your app, or you can ask if you wish.
Can you move?
Yeah.
Okay.
Okay. Just are people on out remotely see the slides?
I am removed.
And you're
And I see it.
okay. Good.
Thank you.
Yeah, this is Youngwan Choi from Korea IETF Korea. This is the IPv6 of OWC. Actually, after the adoption, we have produced two drafts: the initial one and then the another, the revised one, the number one. Next slide, please. Yeah, so this is the status. Today I'm presenting that kind of the update for the draft 0 and the number 1. Next slide, please. Yeah, the initial draft actually the number 1, the 0 is actually the final version of the individual draft. The OW2 actually there's no necessary the sentence like that. So just at the time, just I told you, just we will remove the initial draft. So I just revised that the one, just I put the initial draft like that. And the next slide, please. And then I just put kind of a new the text about the SCHC compression at compression. So just we put kind of the 2 subsection in the section 4.5 in this slide like that. Next slide, please. Actually, the first the subsection the existing the text and the new subsection the 4.5.2 is the SDHC had a compression. Actually, existing text like the left side, but just we put more explanation and just put the new subsection like that. In summary, just the SCHC for IPv6 over OWC actually is also optional. There's 2 topology is one single hop topology kind of the start topology. So in this start topology, just we define the new 6-LoWPAN capability bit in IR6CIO. It's just S flag like that. They support the SCHC for the header compression. So 6 CIO with the S flag only sent by the 6-LoWPAN and the LS, RS, and then the 6-LoWPAN and the RA just may use that the STHC. The next slide, please. The another topology is the multi-hop topology. In this topology, just the whole the 6-LoWPAN is actually network is required to support the SCH compressed packet. The all nodes the must support the same route over mode, like the such as the SRO, TRO, the PRO at the given time. Actually, this mode is defined the previous draft the 6-row SCHC 15.4. So the next slide, please. So just we define the new SC the 6-LoWPAN the capability bits in the 6 CIO. So just we put in the INA consideration that the kind of the information, the bit, the information, this one like that. And after submission, just we got the review from the INA. They just told us the one term in the first sentence is sub registry. Actually, this is not the relevant, so they want to change this one is to just the registry. So we are going to reflect this one the next version. And we also just put the relevant relevant and the new reference for the SCH for IPv6 over MC just to 2 references. One is the SDHC architecture, and the other one is the 50.4. That's all the changes. Thank you.
Okay, are there
Any question about that?
Eric Vink, this time no head at all. I just wonder, out of curiosity, why you select the bit position 47 and not adjacent to the other one. Is there a reason why?
Actually, yeah.
I see Carlos smiling, so it must be a reason.
Well, no particular reason, but it seemed like safer to use that one because yeah, maybe other documents may aim to use some of the reserved bits which are like in the first row. But yeah, other than that, yeah.
Okay.
You know what? The S flag we just put at the last bit, but the other thread to try to put kind of a new the flag like that. We just put at the moment the last. Maybe some of the information the fixed, and then we can move. But at the moment, we just put the last will be kind of significant. And if you just put the last flag bit like this, the figure number 5, then maybe length should be 2, not 1. At the current version of number 1, but actually the length should be 2 in the further the version. Thank you.
Okay, so any other comments, questions? Okay, so thank you. So this was our last presentation today. Is there any other business? Okay, so it seems like we got almost our allocated time of 80 minutes, almost. So yeah, if there is no other common question, the session ends here, and hopefully see you all in Dublin. Thank you.